Okay, so let's take a look at this guy. This is problem number 4. D and E, a 1.6 kilogram mass moves at a constant speed in a 0.767 meter radius circle in the end of a rod. The top this requires an upward force, so we have to actually lift it up. So this, by the way, we know the acceleration is going to be less than 9.81 because of that, right? Okay, so let's figure this out. I think we got to figure out, let's figure out the force of gravity. So here's this thing going around a circle. At the bottom, we don't know, but at the top, we've got an upward force of 6.30 newtons, right? Let's figure out the force of gravity. So 1.6 times 9.81, 1.6 times 9.81 is 15.696 newtons, right? Okay, so now let's see at the top, let's figure out, let's set up F equals ma at the top, right? So at the top we've got 6.3 newtons positive, right? Notice it says upward, right? So that's where the positive comes from, right? Minus 15.696 equals 1.6 times A. So we're going to solve for A. Okay. So 6.3 minus this guy divided by 1.6. I'm getting negative, the acceleration is negative 5.8725. Right, so this means that our centripetal acceleration is just in general 5.8725. The reason it comes out negative is that, of course, at the top we're accelerating down, at the bottom we'll be accelerating up, right? Okay, so what does it say? What's the period of motion? So let's use A is 4 pi squared r over t squared. So 5.8725 is equal to 4 pi squared times, what's our radius? 0.67 times divided by t squared, right? This is clever mathing here, right? Remember, you're going to go all of this, divide by this, that'll be t squared, and then you got a square root, okay? So 4 times pi squared times 0.67 divided by that, whoops, divided by the opposite of that number. That number came out negative on my calculator. I'm getting 4.5 as t squared, raise it to the 0.5, 2.1222, 2.1229 seconds. So I guess if we had to write it there, we'd say 2.12 seconds. That's an S. Can't you tell? It's all curvy. All right. What force in what direction is required at the bottom? All right, so at the bottom, not much changes. We have some unknown force, right? Minus the force of gravity, that's this guy right here, right? Okay, that equals 1.6. And then this acceleration that we figured out at the bottom will be positive, 8725. Okay, so I'm going to go 1.6 times positive 5.87, right? And then I'm going to add the 15.696. And I get that the force is equal to 25.092 newtons. So we'd say, because it's positive, it's upward, right? So we'd say the force equals 25.1 newtons up. Yeah? Don't forget to label it up. If you don't label it up, you're going to lose a half a point. You want all those points.